In this video, we are going to generate a free SSL certificate from Let's Encrypt and then install it in a Spring Boot application. I will be using Google Cloud for deployment, but if you're in a different cloud environment, the steps should be more or less the same. The source code and relevant URLs will be available in the video description below. And if you want to support the channel, you can like this video or consider subscribing. Thank you. Let's Encrypt is a nonprofit organization that generates free SSL certificates for your website. There's no strings attached. You just need to refresh the certificate periodically. I think it's every 6 months or so. And there are instructions in here on how to use it. So with the shell access, there is this certificate bot tool, certbot. So in here, depending on where you run and what server you have. So the way I like to use it is in a Apache web server. And I usually use Bitnami images because they're easy to deploy. And this is what we are going to do right now in Google Cloud. So I'm in my Google Cloud project. You will need to enable billing maybe for your project, but once you are here, we'll just go to Google Compute Engine GCE VM instances. You can see that I don't have any instance in here, and we are going to create a new instance. And in here in Marketplace, there will be some pre-configured images. I like to use one from Bitnami called LAMP. This stands for Linux, Apache, Web Server, MySQL, and PHP. And we'll just use it briefly, and then we can delete the image when we're done. So in here, if we scroll down, it will give us an estimate of how much it will cost. You can see it's pretty affordable, $4 per month. So we just do launch. And now deployment name is fine. We need to select the zone. You select a zone that is close to you geographically or close to your customers if you want to keep it. For me, I will choose US4A. And yeah, make sure in here at estimated monthly cost, it looks like it selected a very expensive machine that we don't need that expensive. Let's pick like a super small one. Maybe N1, let's see. Yeah, like F1 micro. Yeah, this is the small one. And yeah, everything else is fine. We don't need to do anything else. We just click on deploy. Our instance has been deployed. It says right here that there are warnings, but everything is fine. So if we go back to VMs, to Compute Engine virtual machines, we will see our server running right here. And it has an ephemeral external IP. And the next step will be just to assign it reserved static IP. So I'm going to open a new Google Cloud console in a different tab. I just did right click and open link in new tab. So in here, if we search for IP addresses, we will reserve external static IP. Let's call this one boot-SSL-IP. And we select the same region as our virtual machine, US West 4, and we will attach it to the VM we just created. Okay, we can see here it ends in 130219, and we can just double check that the VM is using this reserved IP. So we can see 130.219. So now we can just access our web server by entering this IP in the browser. And we will see this the name of our image. This is a pre-populated HTML page from Bitnami. And we actually can open this Get Started guide in a different tab. We will need it later. Next, we will generate our SSL certificate inside this instance. But for doing that, we first need to add this IP to our DNS. You will need a DNS to generate a SSL certificate with Let's Encrypt. So I have this zone vladsave.com, and I will add a new record in here. Let's call this one boot-SSL. So we just enter the IP in here. We need to remove the HTTP, just leave the IP, and in here we add 60 seconds. It's not too important for this video. We create the record. And now we can even try it in a new tab. So if we do boot-ssl.vladsave.com, this will be different depending on what domain you are using. We will see that we land on the same page that was generated by Bitnami. Now we can generate the 3 SSL certificates. So if we go to documentation, here in administration, we have this section, create an SSL certificate for Apache. So it says to quickly get started, follow these instructions to auto-configure Let's Encrypt SSL certificate. So they have this tool installed in their virtual machines, and we need to connect to our VM, and we will use this SSH browser window, browser client on Compute Engine. Okay, so now that we have the prompt, we just need to run that command. So this bn cert tool, this is the certbot tool that we were looking at, that was linked from the Let's Encrypt Foundation website. So in here, we need to enter the domains for which we are installing the certificate. So it's the one we registered to the DNS. So it will be boot-ssl.vladsave.com. This will be different for you. It asks us if we also want to add the boot-ssl to vladsave. In our case, we don't want to add. And then there's a warning because it cannot add the redirection. It is fine. It's not a problem. Let me see. Oh, yeah, I misspelled it. It says bool instead of boot. Please fix its DNS. Okay, we need to start over. So that's why we had to add the IP to our DNS, because it will check if it's valid or not. So we do boot-ssl.vladsave.com. Again, we don't want it. We skip this step. Do we want to redirect HTTP to HTTPS? Sure, yes. We agree with these changes. We need to enter our email address. We will be notified when we need to refresh the certificate. We agree with the license. Okay, it told us what files it reconfigured, and now it should be good. If we go back to the browser, so in here we can see we are on our domain with boot-SSL, and in here it says non-secure. And if we reload the page, now it no longer says non-secure because we are on HTTPS. The browser will display this lock, and it shows as certificate is valid. It tells us it was provided by Let's Encrypt. Now we will download the SSL certificate from this VM, and then we can stop it or delete it. So in here, we will look into the location where Apache is located on this VM. So it will be in opt, Bitnami, and then Apache. So if we look in here, there is this directory conf. And if we list the contents of the conf directory, the SSL certificate will consist of these two files, the boot-ssl vladsafe.com.crt, and then there's also a file with the same name but with the key. So we actually just need these two files, but because in about like 4 or 5, 6 months you will need to refresh this certificate, I prefer to download this entire configuration directory, and then you can deploy another VM and replace this configuration directory on that VM, and then run the script that refreshes your certificate. So in here, let's see where we are. So we will just create an archive with that directory. We will do zip dash air for recursive, then the name of our zip file. Let's call it Apache dash SSL dash configuration.zip, and then we just provide the directory with the configuration. So it will be opt Bitnami Apache, and then configuration. And yeah, I'm going to delete the / at the end. Let's see if this works. Okay, so this one worked. We can see our archive in here. And so let's see what directory we are in. So we are in home, then my username and this. So there's this button in the SSH browser client, SSH client in a browser that allows us to download files, but we need to provide the absolute path of our file. So we'll do the path from there, and then the Apache SSL conf.zip. Yeah, let's retry it. Okay, let's try it again. So if we do, it will be home, Vlad, my name, then Apache dash SSL dash conf.zip. Okay, we see that now it worked, so we need to download this one locally, and we will use it later. Yeah, actually, I'll just download it here. And then also decompress this archive. In Mac, I just click on it, but in different operating environments, you'll need to extract this zip file. So we can see in here the CRT and key files for our certificate that were generated from the server. The problem is that Spring Boot and Apache, they use a different format for certificates. They need key stores. So if we search for Tomcat SSL, there will be this page in here, and it tells us, if we scroll down a little bit, it will tell us the formats that are supported by Tomcat. So there will be JKS, PKCS11, and PKCS12. So we will need to convert our certificates to this key store format. And here they actually have a command on how to achieve this. So there's this OpenSSL command that you need to install locally, and we will run this in the terminal shortly. So you will need to open a terminal window, then navigate to the directory on which we extracted that configuration zip file. I think it'll be in opt Bitnami Apache configuration in here. So in here we will see that we have the CRT and the key file. And we need to adapt this command. You have to make sure you have open SSL command installed. In my case, I do. So in here, we will use pkcs12 export. Then we need the in argument. So it will be in, and in is the CRT file, so it'll be boot.crt. Then we need the in key argument. In key will be the key file, .key. Then we just need the out argument. We don't need name, CA file, all that stuff. We just need out. So it will be out. Let's just call it server. The extension will be P12. So server.p12. And it asks us for a password now. I'm just going to use 1, 2, 3, 4. But in your case, obviously use something more secure, more random than that. And if we look here, what happened, now we have this server.p12 file that we generated from the certificate and key. And this is the one that we will use inside Spring Boot. Next, we will generate a new Spring Boot project using the Spring Initializer. Actually, I'm just going to move this off screen and do some cleanup in here. So I'm going to use the Spring Initializer website. In here, yeah, Gradle Groovy, that is fine. And yeah, let's call this one boot SSL. And we will need to add the Spring Web and also the developer tools, sure. So we need to generate this project and then open it in, I will use IntelliJ, but you can use other IDE or editors. So in here, yeah, that one is fine. Also extract the archive. Okay, so I opened our project inside IntelliJ IDEA Community Edition, and we will start it now. So in here, if we go to the main file, we can turn our application into a REST controller. So we add the REST controller annotation and just add an endpoint in here. Let's do like a hello world endpoint. Hello world, let's add SSL. Okay, so we also need to add the get mapping annotation for the root path. Make sure we import everything with Alt-Enter. We see the imports were added right here. And now we are going to run our server with this run configuration. Okay, we see our server has started. It's running on port 8080. So if we just visit localhost 8080, we will see the endpoint we just created. Now we will configure our Spring Boot application to use the P12 certificate we just converted. So if we search for Spring Boot SSL, and inside their official documentation in here, there are the configurations listed that we need to do. So from here, some of them are actually optional. So we need the server.port, and actually we will create a different profile in here. So we will do inside the source main resources. We will create a new file in here called application-prod for production.properties. So we need to transfer the server port to 443, which is the default HTTPS port. Then we need the key store. So server.ssl.key-store, and then we need the key store password. That's all we need. We don't need the other stuff. So it will be server.ssl key store. And for this, we actually need to transfer the P12. We need to copy the P12 file we just generated earlier inside the resources directory in here. I'm just going to drag it from outside the screen, and we can see it right here. So now the path will be class path colon and server P12. The path will be relative to resources. And after that, we also need the server.ssl and key store password. And this one will actually going to pass it through an environment variable. It's going to be called SSL_password. So this profile will only be applied when we are running the production profile. Locally, it will use the default profile that doesn't have any properties at the moment. Now we are ready to deploy our Spring Boot project to Google Cloud. And I'm going to create a Docker image out of our project and then deploy it to Google Cloud. That way, I have another video that will show up as a card at the top where I go slower and step-by-step explain everything. I recommend watching that one if you haven't deployed many Docker, if you haven't deployed Spring Boot with Docker on the compute engine. So now we are going to use the Gradle Gib Docker build plugin to create the Docker image. So from here, we need to add this to our Gradle file. Let's see, in build.gradle. So inside the plugins section, we need to add this one. Then, we need to add the destination image for our project. So in here, we need to fill in our project ID from Google Cloud. So if we go to the Google Cloud console in this drop-down menu, we need to copy the project ID from here. And then we also need to give a name to our image. We're going to call it boot-SSL as well. And also in here, there's an annoying bug in this plugin where the creation timestamp is set to 1970, and it's confusing. It's not very good. So we need to configure the inside the container, gib.container, and creation time. We will do use current timestamp. So it will be gib.container.creation time, and I'm just going to copy this one from here, use current timestamp, like that. Now we need to reload our Gradle file. Actually, let's stop our project briefly. So we need to reload the Gradle file. Actually, I saw that, I'm not sure what this error is about, but one way to address this is to use a different version for this Gib Gradle build. I'm going to use 3.1.4 that I know it will work. So let's try again. Yeah, now it's probably fine. So if we go to this Gradle section in IntelliJ, inside task, Gib, we need to run this one, Gib Dogger build. Oh, yeah, it says your project is using Java 17, but the base is Java 11. So the workaround for this, it will be, I'm going to put this Gib base image. So the gib from image, it will be based on OpenJDK17 Slim. So we reload the Gradle changes again. And now we can try this gib docker build again. And yeah, this time it looks like it's working. So now in the terminal, if we list the Docker images we have on our machine, we will see that there's boot SSL that was created 23 seconds ago, which is good. So now we just do a Docker push on with this image. So if we do Docker push, you need to have your Docker client configured with Google Cloud if you are getting errors in here. Check out my other video to see how to do that. And yeah, it will take a little bit just to upload this image. Okay, the image has been pushed, and we can actually check now in Google Cloud. So if we go in here, if we open a new Google Cloud console, so we just navigate to container registry. Just search for container registry in search bar. And we see here the boot SSL image, which it says created 1 minute ago. And yeah, this is the one we are going to deploy. But before we deploy it, we need to release the reserved IP from our LAMP deployment from the Apache server we deployed earlier. So for this, we need to stop that virtual machine. Okay, once the virtual machine is stopped, we can edit it. And in here, in network interfaces, it says external IPv4 address, and it's the IP address we reserved. And instead, we will select ephemeral and save this change, the edit we just made. We can also delete this instance and this deployment. Actually, if you want to delete the entire deployment, you just search for deployments in the search bar, and it will take you to a place where you can delete this Bitnami configuration. Anyway, while it's saving, we can start on actually deploying our image. So if we just go to ... we will do deploy to GCE. Let's call this one boot-SSL. We need to select the same region we used before. The machine type, I'm going to use a small one. Always keep an eye on cost. Sometimes it gives you expensive machines by default. And in here, inside container, we click change. The image name is fine, but we need to add some environment variables. So the first one will be Spring Profile Active. Actually, is Spring Profile Active or Spring Profiles Active? I forgot. Yeah, it's Spring Profiles. Spring Profiles Active, okay. So with an S. And here we need to do prod. So this one will needs to match what we put after the dash in application prod properties. So this way it will run the SSL configuration changes. And then we also need to add an environment variable for this SSL password. So in here, we do SSL password and we do 1, 2, 3, 4. Okay, this is good. And now we need to, on firewall, we need to allow HTTPS traffic. And in advanced options inside the networking, we need to use our reserved IP that we just released from the other VM. So if we go to external IP addresses, we will see that now we are allowed to assign it to this new virtual machine. So in here we will do done. Okay, so HTTPS is still selected, and now we just click on create. Okay, actually let's refresh. Let's see if the IP is the same one we used. Yeah, it's 130.219, and in here it's 130.219, so it's the same one. So now if we go to, actually if we open our website with HTTPS, how is it, boot ssl.vladsave.com. Yeah, we need, it's cached in the browser. We just need to reload the page. And now we see the Hello World SSL, which is coming from our Spring Boot application. And there's this lock in here. And if we go to certificate is valid, we will see that it's the same certificate that we were using earlier. This is all the material for today. There is more Spring Boot content on this channel if you want to continue watching, and if you have questions, let me know in the comment section below. Thank you for watching.